Hi geometry students. These notes are on proving a quadrilateral is a parallelogram. Um, and I want to make a connection for you. So first of all, we've been doing a lot with quadrilaterals and specifically parallelograms, but we haven't yet delved into proofs that involve them. And the idea here is there's going to be like certain properties that when we see them occurring, that will be enough to conclude we know it's a parallelogram. And it's kind of similar. There's kind of like this like connection or similarity to when we were doing triangle congruence. Like we only needed a certain kind of sets of information. Like if we had all three sides congruent, then we knew the triangles were congruent. If we had like angle side, we knew the triangles were congruent. Or side angle side or angle side, right? So this idea that like there's certain kind of sets of information that once we have it, that will be enough to conclude that two triangles are congruent. Similarly, there's going to be certain sets of information that if we see a quadrilateral has that information, we're going to automatically assume we're going to be able to conclude it is a parallelogram. Okay? So to get us thinking about that, we have this little opening exercise for you, and it says, does it have to be a parallelogram? If. So the key is like have to. So what we're going to do here, and I'm going to have you pause the video in a moment to try this out on your own, but as you read the statement, you're going to try to decide, does this mean it has to be a parallelogram, or would it be possible to draw a quadrilateral that meets the requirement but isn't a parallelogram? So it says like it has one pair of opposite angles that are congruent. It might be a good idea to take out some of your notes that like deal with all the different properties, because like for example for this one, I remember that a kite has one pair of opposite angles that are congruent, right? Like in a kite, you could have these two angles would end up being congruent. But a kite is not necessarily a parallelogram. And I'm using this notation to mean parallelogram because I didn't want to write it all out. So then I would say no for the first one. Okay, so I'm going to have you pause the video, run through these. You can draw a picture if it helps you, but I want you to try to select which ones do you think guarantees it to be a parallelogram and which ones do not. And then I'm going to kind of share out my thoughts. Okay, so pause the video, try this out, then press play. Okay, so if I'm running through, so at this point you should have tried this on your own. Now I'm going to confirm your answers. It says it has two pairs of opposite angles that are congruent. So if you start drawing this, maybe I kind of draw opposite angles like that, and maybe another set like that, and I'm just trying to like eyeball them being congruent. That looks pretty parallel. These look parallel. These look parallel. So right now it's like kind of hard for me to come up with a situation where if I draw it that way, I'm not going to get a parallelogram. So I think yes. It has two diagonals that bisect each other. So similarly, I could try to draw a picture where it's like, okay, suppose that's a diagonal, and that's the midpoint. And I draw another diagonal through that, and I also want to make it, so like these are congruent, these are congruent, and then I connect. And I'm thinking right now, that looks like a parallelogram. So I'm going to say yes for this one. And again, I'm not sure, but I'm just kind of trying to see if I can come up with something that's different. The next one says both pairs of opposite sides are congruent. So if I kind of draw something where I have opposite sides being congruent, I can kind of like say, okay, let's say this is congruent to this. Then if I connect them, this is congruent to that. That looks like a parallelogram. Maybe if I like don't make one pair parallel, but they are congruent, then that automatically means like the other two sides aren't congruent, right? So that doesn't work. So I'm thinking right now, yes. It has one pair of congruent sides and one pair of parallel sides. That makes me think of an isosceles trapezoid, where these two sides are congruent and these two sides are parallel. And that makes me think, well, that's not a parallelogram, so I would say no for this one. And that last one, it has a pair of sides that are both congruent and parallel. So if I draw kind of like two little segments that look about the same length and are parallel, then when I connect them, that looks like it automatically makes a parallelogram. So I'm thinking yes for this one, okay? And this, because I know kind of where I'm headed, this ends up being the case. Okay, so what we end up coming up with is a list of reasons of kind of like requirements. Like if we know this thing to be true, then we know we will be able to prove that the quadrilateral is a parallelogram. Okay, so we're going to kind of list them out, and I'm going to do some abbreviations, so just kind of be aware of that. And if you don't want to do the abbreviations, you could write out the whole word. But the first one is going to be, the first thing I'm going to write here is like is based on the definition of a parallelogram, meaning to have two pairs of opposite sides. Two pairs of parallel opposite sides. So the idea is that we're going to kind of write an if-then statement. So we'll say if both pairs of opposite sides, and I'm going to abbreviate opposite with op, of a quadrilateral, I'm going to abbreviate with quad. So if both pairs of opposite sides of a quadrilateral are parallel, remember our abbreviation for parallel, then my conclusion is going to be, then it is a parallelogram. And instead of writing out parallelogram, I'm just going to draw a little sketch of a parallelogram. Okay, so that's my first one, and this is by definition of a parallelogram. Okay, so this is kind of like by definition. So my next one is going to be, if both pairs of opposite sides are congruent, then it is a parallelogram. And that is based off of D, right? Both pairs of opposite sides are congruent. So if both pairs of opposite sides are congruent, then it is a parallelogram. Okay, the next one is going to be, and the next one is going to be based off of F, if it has a pair of opposite sides that are both congruent and parallel, but only one pair. That's enough, okay? So I'm going to say if one pair of opposite sides are congruent and parallel, one pair of opposite sides are congruent and parallel, then it is a parallelogram. Next up, if the diagonals bisect each other, that's C. Then that's also going to guarantee it's a parallelogram. And my last one is going to be, if both pairs of opposite angles are congruent, then it is a parallelogram. Okay, so the idea now, so this one was by definition, and these ones are, some of them are based off of the properties that we already knew about parallelograms, and some of them are like the one that's like if one pair of opposite sides are both congruent and parallel. That one can actually, this is a theorem that can be proved. Okay, so all of these really can be proved using kind of our prior knowledge about triangles and parallel lines. Okay. So the idea of the next part is we're given a picture that includes certain information about the parallelograms. So it says for each quadrilateral quad, state the property or definition, if there is one, that proves that this is a parallelogram. So if I look at the first one, based on how the diagram is marked, it's showing me that the diagonals are bisecting each other, right? So which of these is that? That's number 4, right? The diagonals bisect each other, then it's a parallelogram. And for the sake of time, I'm just going to kind of like correspond it to one of the numbers 1 through 5 up here. So this is number 4. And I'm going to have you guys pause the video and try these out. In this picture, it's a little bit hard to see, but these two marks mean parallel there. And same here. So like if you're having a hard time seeing, those are the parallel arrows. Okay, so pause the video and then we can come back, press play when you're ready to check your answers. Okay, so now if you press play for B, it's giving me one pair of opposite sides congruent and parallel. So that's number 3, right? In C, it's giving me both opposite sides are congruent. So that is number 2. Both pairs of opposite sides are congruent, then they are parallel. This next one, it looks like, I was like, you might be confused by what these two angles are telling you, but the idea would be that these are alternate interior angles being congruent. So that should lead us to conclude that these sides are parallel. So that should tell us that we have two pairs of opposite sides parallel. That's by definition. So that's number 1 on our list. And then the last one, I kind of went out of order. For D, we have one pair that is parallel, one pair that is congruent. This is that case from the opener that doesn't work. So we can't prove here. Okay, so moving on to the back, let's take a look and see. Some of this you're going to end up doing on your own, but I wanted to kind of preview it and see so we can kind of understand what's going on. The first example is related to what we've been doing on the coordinate plane, where we've been plotting points and finding slopes and distances, except now we're going to kind of use that same justification in the context of these different ways to prove a quadrilateral is a parallelogram, right? So it says, in 3 different ways, show that this is a parallelogram. Well, if we think we know how to, we can do this using the distance and slope formulas, right? We're going to use distance just like we were doing earlier in the unit. And the idea is, well, if I want to show, say, so like if I kind of run down my list of things on the front and think about what can I show using the distance formula or slope formula, certainly I could do number 1, that opposite sides are parallel using slopes. I could do number 2, opposite sides are congruent using the distance formula. But I could also do number 3, if one pair, just looking at one pair and showing it's both congruent and parallel. Okay, so I end up being able to use 1, 2, or 3. And we're actually going to take some time to do all 3. So we said one thing I could do is both pairs of opposite sides are parallel. Right? And I'd have to use slope formula to do that, and I can kind of set that up. Another thing I could do would be both pairs of opposite sides are congruent. And then to do that one, I'd use distance formula. And then the last way would be one pair of opposite sides is congruent and parallel, in which case I'd have to do both, one like distance formula and slope, but just for one pair of sides. So how does this work? We'll do number 1 together, and then I'm going to leave 2 and 3 for you guys to try. So for number 1, if I want to show both pairs of opposite sides are parallel, then I need to find the slope between all of the different sides, right? So the slope for PS from these 2 points, it would be y2 minus y1 over x2 minus x1, right? So I'm going to do negative 4 minus 6 over negative 7 minus negative 10. So I end up getting on top negative 10, and on the bottom, this ends up becoming addition, right? So I get positive 3. So I have negative 10 over 3. So now I would like to check if that's the same for QR. So I would do 6 minus negative 4 over 2 minus 5. And I get negative 3 over 10. And even though the negative's in a slightly different place, these are the same. So they are. I have one pair of opposite sides parallel. Now I just need to check the other pair. Well, that's actually a little easier because the slope of PQ ends up being, I'm going to do like 6 minus 6 on top, so it's just going to be 0, right? Because then I'll do like 2 minus negative 10. Doesn't even matter what that is. This thing is going to be 0. I also kind of know that because I see it's a horizontal line. Same thing for SR. That's also going to give me a slope of 0. So I end up with two pairs of opposite sides being parallel, and I've shown my point. Okay? So now you're going to pause the video. You're going to try out. Well, actually, I actually don't have so much more to say because I'd like you guys to show it using both pairs of opposite sides, and one pair of opposite sides is congruent and parallel. So you're going to set that up for both of those. And then the last thing you guys are going to do is you're going to try to fill in the proof at the bottom. Okay? We will definitely talk about this proof, but I want to see if you can kind of follow the reasoning laid out in the fill in the blanks and see what goes in those blanks. So do the best that you can, and we will be practicing all of this in class on Friday.